All right, time for section 4.5. We're going to skip around here a little bit and do this section. We're going to cover two other ways to know that triangles are congruent. Let me apologize. First of all, that light bulb that was flickering, it went out, so it's a little bit dark in here. Hopefully you can still see. But let's keep going here. So the other two ways, we learned about side, 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 and angle, side, angle. This one, which I think I may have previewed for you, is angle, side, or angle, angle, side. If two angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. What are we talking about here? Well, all right, for angle, angle, side, we have these two angles are congruent, and then we have these two other angles are congruent. If we know that angle and angle, and then a non-included side. The included side of this triangle would be GX, and the included side of this triangle, of these two angles, it would be side DC. So the non-included side, or a non-included side, in this case, we're talking about DM and GT. This would go, if we're going in this order, angle, angle, side, or angle, angle, side. It would be side, angle, angle as well, but we're not going to call it that. We're going to go angle, angle, side. So then we can say that triangle CDM is congruent with triangle XGT, or we could say it a different way, as long as we have corresponding parts matching up. And now that we've just used these three parts to say that we have congruent triangles, now we can say that all of the other parts are congruent as well, CP, CTC. There's a real simple reason for this. It's that we could have used angle, angle, side, but we don't have to do this. If these two angles are congruent to these two angles, then angle M has to be congruent to angle T because they all add up to 180. There's the theorem that we learned in our last chapter that talked about if two angles of one triangle are congruent with the two angles of another triangle, then the third angle is congruent. And if we had done that, we could go these angles congruent and gone angle, side, angle, but we can skip that step and just go angle, angle, side. So it just makes life a little bit easier. So there's the fourth reason that we can add along to side, 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 angle, side, and angle, side, angle, 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 side. There's one more, but before we do it, we have to talk about right triangles and some terminology here. I've mentioned this before, but there's some terminology that we have to know. The two sides that make the right angle of a right triangle are called legs. So in this right triangle over here, that we have a leg and a leg. Okay? The long side, the side that is opposite the right angle, here's what I mean by opposite, here's the right angle, is opposite on the other side of it. It's always going to be the longest side of the right triangle, is the hypotenuse. Hypotenuse is the name of that word. We're going to hear that over and over and over again for the next several months. So we have legs and hypotenuse. Long sides, hypotenuse, two short sides are the two legs. Okay? Now, that leads us to this HL theorem. This is the fifth and final way that we can say that triangles are congruent. If the hypotenuse and leg of one right triangle are congruent to the corresponding parts of another right triangle, then the triangles are congruent. So this is the only one where we only use two pieces. Well, in fact, we do have three pieces. We have the right angle, and we have two sides that we're talking about. But if we have, in this diagram here, we got, of course, two right triangles. If the hypotenuse is congruent to this hypotenuse and the two legs are congruent here, we can use the HL theorem to state that these two triangles are congruent. And then, of course, we can use CP, CTC as well. So this is a special piece that only goes with the right triangles. We're going to learn a lot more about right triangles in the third quarter. That's going to help explain why this is what it is. But for now, let's just go with this. Well, just know that if you have a hypotenuse and a leg, that's congruent to another hypotenuse and a leg of a right triangle. HL is our reason. Okay, so here's some examples. Example A, B, and C. State which method, and now we have 5 methods, and sometimes you'll see more than one. What does this diagram have for us? I got a right triangle, so if a right triangle, I need to be on the lookout for HL, hypotenuse leg. Also have parallel lines. When there's parallel lines, I probably have alternate interior angles, and I do in this case. I also have vertical angles. So of all the stuff that we know here, hold on, sorry. I got parallel lines, I got angles that are congruent, but I don't know anything about the sides. All I have is angle, angle, and angle that's congruent. So do we have congruent triangles? No, I don't know anything about the sides. We have no congruent triangles. Okay, so we need to know something about the sides. Here we go on question B here. I got a right angle, I got this leg that's congruent, and then I have a shared side, reflexive. So I have the reflexive side here happens to be the hypotenuse of this triangle and the hypotenuse of this triangle. It's the biggest side, it's opposite the right angle. So I have hypotenuse and leg are congruent of a right triangle. That's the HL reason. Okay, do I have another reason? Well, I would have angle, side, side. No, that's not one of our reasons. Donkey, no good. Okay, question C. I have angle and an angle, and then I have this given side. Well, what did we learn just above here? There's angle, angle, side, angle, angle, side. Yes, we have congruent triangles. I also have this reflexive side here, this side that's in both sides of them, or it's both triangles. So I have angle, angle, side, or angle, angle, side. In the red here, I got angle, angle, side, but I could also go angle, side, angle. I'm sorry, I pointed the wrong way. Side, angle, side, angle, side, and then angle, side, angle. There's 3 reasons that we could say that we have congruent triangles right there. Okay, try these next 8 questions. Be on the lookout. Oh gosh, I see some parallel lines. That may have to do with alternate interiors, perhaps. Ooh, I see some right triangles. Maybe those are HLs, perhaps, but maybe not. Give them a shot. Okay, how did you do? Let's see. Parallel lines, yes, we got alternate interior angles all over the place. There's your angle, side angle. We also have vertical angles there, so if you wanted, you could say angle, angle, side, I suppose, as well. Let me put that in there. Angle, angle, side is also a reason. Here we got the reflexive piece. That's not HL because we don't have the hypotenuse. That's side, angle, side. The right angle is our angle there. Here we have alternate interior angles that are congruent, and we have side, angle, side is our reason. The parallel lines over here don't really help us. Although they could, we could also say, I suppose, that these angles are congruent and go angle, side, angle. And if we can have that, then we could also, in this case, have angle, angle, side. So there could be multiple reasons there. On number 4, we have, let me clean that up. Here, did you see the angle, angle, side as our reason? Then we got these answers down here on the bottom. How did you do? Okay, this is, there's not much more to what we got going on here, but try these 4 as well, please. Do you agree? We have bunches of reason there for that last one. We could side, angle, HL. If you got at least one of them, we're in good shape. All right, last piece of this puzzle is when we have overlapping triangles. This isn't just simply a shared side, it's when we have some traffic going on. To make these simpler, here is what you need to do, or what I'm going to teach you to do. Please do this. Redraw the triangles. Okay, just separate them. And then, of course, mark them the same way. I got a right angle, I got a side. If somehow I could show that this side over here is congruent, I have side, angle, side. If I knew something about an angle, ooh, it's a right triangle, maybe I have HL. So yeah, so we got this given. Then what else is true? Well, these 2 triangles both have XZ. That's the same XZ, so they're congruent. So do we have congruent triangles? Yes. There's the hypotenuse, there's the leg of a right triangle. We have HL is our reason for these 2 congruent triangles. Splitting it up helps things just make more sense. So please do that. I'm going to do the same thing over here on example B. So draw whatever it tells us. I got angle A is congruent with angle C. Find the reflexive piece. The reflexive piece is the one that's in both. Angle B is congruent to angle B. That B is congruent to itself. It also told us in the given that AE is congruent with DC. So we end up with all of these pieces. Reflexive, given, and given. Angle, angle, side, angle, angle, side. If you go the other way around, side, angle, angle, I hope you'll know to reverse that. So yes, we have congruent triangles. So the key, this whole part of this lesson is about redrawing the triangles. So I'll help you out, at least this much. That's what those triangles should look like if you redraw them for both 9 and 10. But different situations on 9 and than 10, give those your best effort. For all 4 of those, pause it. The reason that you should have come up with on your own instead of just copying these answers right now is for angle, angle, side for number 9, angle, side, angle for number 10, angle, side, angle for number 11, and an HL for number 12. So if you're still paying attention, like I'm sure that you are, if you'll just put a triangle right here, please. Okay. Thank you for paying attention and for doing your best. Hope that made sense. Please get some rest and be ready to ask questions when you have them.